Okay, so the recording welcome team for another session of the data engineering training. I think we are all doing good. Have a good hang of the Databricks platform, PySpark notebooks, processing, the batch jobs, ETL, all the basic concepts. And I think we touched upon a bit on the cloud computing last week. What are the cloud platforms, what features, services they offer, and what are the more popular tools that each of these platforms offer, other than storage, basically, and how Databricks or Snowflake can be um, deployed on any of these clouds and then used. Today, we will go into file formats. Basically, we looked at CSV file processing in Databricks. But again, I think when we go, um, so when we go into the next thing, right? So what we'll do is we'll do some file formats. So CSV is one of the uh, popular formats, and other than CSV, JSON is the most preferred file format uh, for for most of the file wherever the files are available, right? CSV and JSON. Okay, there are some other file formats. For example, XML. XML also, I mean, it was popular earlier, but right now it's mostly JSON is more preferred. Um, and then you have Parquet file format. That's the de facto standard for Databricks to store because it's a machine readable format. So some files are machine readable, some files are human readable format. So we'll talk about file formats, processing the JSON file using our notebooks, right? If the data comes in as a JSON file, then we will talk about storage S3 on AWS. How do we put files and then access files from S3, create buckets and files and all of that? And we'll talk briefly about it. So tomorrow we will look at a use case on the AWS, and I will introduce some more tools or concepts on the AWS, and then we move on to the next tool. So basically, how it will be doing is we will take Databricks as a platform. It will continue in parallel with all other concepts wherever we can touch with other tools. And then the another track that will run in parallel is about the tools like AWS, Azure, Kafka, Snowflake, and Airflow. So these tools we will keep touching upon every week, some new tool. And then in the parallel, we will also be covering Databricks in full, kind of. So 50% of it will be on Databricks, and another 50% will be all of these cloud services, tools, everything that would cover. So that will give you a comprehensive understanding of the data engineering layout, and you get expertise or exposure. Sorry, not expertise, exposure to all of the um, tools that are used in the data engineering. How does that sound?
Yeah,
Okay.
sounds good.
Sounds good.
All right. Great.
Sounds
Great.
good.
Okay. So let me share my screen. So let me. Uh, all right. This is still having issues with the laptop. Okay, I got it open. Share my screen. All right. So once we have, oh, this is gone again. Just bear with me for a second. Try to get this up. Okay. Can you see my screen?
Yes, we
sir.
can. Yes, sir. Yeah.
Okay. All right. So let's talking about the file formats, right? So let's talk about the file formats today. So we'll go here, take any page. Okay. Now, what are the file formats we talked about? We processed. What are the file in general file formats? We have a text file, right? Text
Yeah,
file is
text
normal
file.
text file what we use, right? And then we
CSV.
worked on CSV files. CSV files is basically like this. These are the CSV files, comma separated, correct?
Mhm.
So each variable or each data point is separated by a comma. So whenever it sees a comma, it splits into the next cell, right? So same thing we have like Excel files. So CSV is a version of Excel. Excels are by default tab separated. CSV is like something you can open in text format also. It shows a comma separated file format. And within the field, say for example, within this, if you have a comma inside it, some there will be some issues when you parse and read that. So within that, when the file internally, when it sends the data, it will again incorporate that particular element in a double quotes. So if you see here, for example, in the comma separated, see only this one has double quotes here. See, these ones don't have, because here if you see there is a comma in the data itself, iron lady the, okay, so something. But if you just leave it like this, then there will be a data skew, data will be shifted, right? So this will come in id, this will come in name, and this will go into the genre, because the next field separated by comma is genre. So there will be a data shift, and that will cause issues. This will be left out. To avoid that scenario, CSV file embeds that data point whenever there is a comma within that. So it will embed in a double quote, so that the job or the program that is parsing, it will understand that, okay, though there is a comma here, since it is all embedded in a double quotes, this entire thing is one field. Okay, so this is how the program will interpret, and these are kind of your CSV file. Now, apart from CSV file, there is something more, as I said, popular one. So we know Excel, but normally we don't process any Excel files. And generally, you have other things like what are the other file formats? Tell me. Every day you are coming up with, you'll be looking at so many files. Right?
JSON.
JSON will come. Okay, JSON will talk about JSON, say, for processing. Other than, forget about processing data files. In general, daily, what do you see? You do so many attachments, right? You send so many attachments. What are the files
Yeah,
that?
PDF.
Yes, okay, PDF. Okay,
What?
Word, yes, Word document, yes.
.png.
Okay, image files.
Image files.
Okay. Yeah, PNG is a format. You're right. Yeah,
Mm.
.png, .gif, right? So
Mm.
all of that, yes. Okay. What next? Okay,
Next.
Word, we have got PPT files, we have got Excel, Word, CSV, text file. So now comes data formats, right? So let's say JSON.
.dat.
Oh yeah, dot. Okay, dat .dat file is mostly data files, right? So
Data files. Yeah.
extract some data from database, you get .dat files, right? Yeah, no, I know that. So yeah, that's a good one. So .dat files. And
XML,
yeah, Rahul?
XML file.
Yes, okay, XML file. Okay.
And also, importantly, a Parquet.
Okay. And there's something called ORC. There's something called Arrow. There's something called Iceberg. Iceberg is a format. Okay, we'll see. For now, yeah, let's consider that. So these are all the file formats. Okay, basically, all of them have data, some kind of data, and then you interpret that data. Some of them you can directly human readable. Okay, all your text, CSV, Excel, PDF, Word, PPT, JSON, XML, or your human readable formats, which means you can look at with your eyes and then read the information and data. There are something called machine readable files, so which you cannot read. It's all like binary, and when you open it, you see like gibberish things, right? That can only be interpreted by the machine because they are all encrypted, and then they have some algorithm, and only the systems, the machines can understand those kind of files. Even say when you say so .java is also a text kind of a file, but it's a Java file. You can compile, it gives you compiled code which can only be read by the machine. Okay, something like that. So Parquet is one of the machine readable format. ORC is also machine readable format. Arrow, Iceberg, and .dat is also machine readable format files. Okay, so that can be interpreted by some machines which can read those specific file formats. Typically, same thing with audio and video files, right? Let's say you have an audio file and video file. Can you open and read it? No, so you have to
No.
play. Yeah, you have to play, use some kind of, not play, you have to use some kind of tools that can understand those file formats and then play it for you. If it is an audio, they play audio, generate audio. If it is a video file, they generate, .mp4. Or so whatever are the video files, audio files. So based on, you have audio players, video players, those software that can read those files. Correct. Now, so all of this and image files, .png, GIF, and all that. So in the data world, machine readable, human readable is one kind of differentiation. But then there are also like structured, semi-structured, and unstructured data files that some structured data that you call. It's not, it's a little bit of vague. Some people call something and some people call something, but typically, if you have a database, you're reading from a database in a relational, like tables, columns, that is mostly considered as structured data. So it has a structure, schema, table name, data types, and columns, and it's all it's all very structured and attached, linked to each other. So that's a structured format when you're reading data from tables. Reading from files, it's considered semi-structured, basically. It's considered semi-structured files where you have text, but you don't have a schema yet. It's a free-flowing text, like text file, Word file, CSV, JSON, like these have some kind of structure, but they are free-flowing format. So sometimes they are called semi-structured, sometimes they are called structured files, kind of a thing. Okay. But specifically PDF, audio, video, or audio, video, image are called unstructured data. So there is no structure to it. Okay. In the data engineering world, so mostly we have structured data and semi-structured data, like we use JSON, XML kind of for reading purpose. JSON, XML, audio, so not audio, JSON, XML, CSV. So we use semi-structured data and PDF, so semi-structured. So these data types we use to ingest or read data and process data. Mostly PDF data and word text data, free flowing like text, let's say blogs, stories, all of the text files that you generate or PDFs. They are used mostly to consume and parse data and use for machine learning or Gen AI kind of use cases. They are mostly used. Basically, your PDF text files, the files. CSV and the JSON files, XML files are used for data ingestion in data engineering. Also, in that, mostly it will be CSV and JSON. Once it is processed, it will be stored in the storage, mostly in a machine readable format, so that it can quickly. So there are some security concerns issue that you have to address. So they will be encrypted. So data will be encrypted when they store it. They will not store just as a text file so that anybody can go and open the file and read it. So they will be encrypted and then stored in a specific format, machine readable format, so that machine can read it faster when you ask for it. So Databricks uses Parquet format to store the files. When you read a CSV file, or when you read a JSON file, or you read XML file, or you read data from anywhere, you process it and then say you are writing it to database, right? So when you're actually saying write to database, write to a table, table is just a front, a kind of a wrapper. Behind the table, the actual data is again stored in files only. But that file will be different. It's not like same CSV file it will go and store. So that file will be, say, Parquet file, and it is encrypted and it is compressed and encrypted, and then stored in the path where your table is situated or located to, where the table can read from that path those files. So we will go detail into how Databricks stores these Parquet files, what is there in Parquet files, how it every time it does some transaction on the files, how it processes. It's all in a Databricks Delta session that we will talk about. Okay, but Parquet is one file, ORC is one, Arrow is one. So these kind of files, they store it and then they can read faster because they are machine readable, and then they are encrypted and they are compressed. So it is they are optimized for performance, for reading and writing. Okay. So from the data engineering perspective, you should know what are all the files. We work with CSV. So we will talk about JSON. XML is a little bit less. I can give you some kind of context you can explore and look at it. So we'll do about how to parse and work on the JSON files. Okay. So any questions on this?
No, Harun.
No.
No. Okay. Okay. Let me check this. Movie links. Where are my JSON files? Okay, here. Sure. Okay, so first things first, I need to create a compute. Let me create compute 1 second. Just give me a minute until this comes up. All right. So the compute is coming up. Okay. Meanwhile, I will go and look at the JSON files. Okay. Now, if I go here, so let me open and see a simple JSON file. How many of you have worked with JSON files earlier? Looked at, understand JSON structure?
I did, sir.
Okay,
Yeah,
obvious.
I did.
Yeah, I did as well.
Yeah, so good. Okay, nice. All right. So I think you have some context about it. That's fine. For the benefit of everyone here, I will give a quick summary of how the JSON file looks like. So this is the format of a JSON file. JSON stands for what is JavaScript object notation. So that's where it started with, with the JavaScript kind of thing. Later it became standard, popular. So in JSON file, everything will be viewed as a key value pair. A key is something like column name, and value is the value for that key. And also each record will be enclosed in the curly braces or flower brackets, whatever you call curly braces, this ones. So from this to this is a one record. Now, if you go into Python, so in Python, this is represented as a dictionary. See, there are two important object notations or two important collections that you need to be very comfortable with in Python. One is a list and the other one is dictionary. Okay, so list is a collection of items, just like a list of items that are enclosed in one group. So they are called list. Just like let's say flowers is a list, then you can inside it you have names of all the flowers separated by commas. So that will be one list. Fruits, if you talk about apple, banana, and all of that, so that will be list. So if you want, we can explore that sometime. So, but that is a list. In dictionary is something like this. So it will have a key and a value. Okay, so key is name, value is John, age is 30 because it is integer, it's not in quotes. City is New York. So this is one record, this is another record, this is another record. So this is a simple JSON structure. Okay, now the next level of complexity comes when there is more elements within the dictionary. So if you see here, from this part to this part is one element, and from this part to this part is one element. But we are doing it in multi-line. So it's not there all in one line. ID, name, attributes is again a list, dictionary within that record. Okay, so it again has attributes again as a key value pair inside the record itself. Okay, so this is the record, then you have key value pairs here, and this is the record. These are attributes, ID and name, variables, fields, whatever you call, ID, name. But again, there is a element called attributes. It's a dictionary which has hair color and eye color. So this is one record and this is one record. So this is the nested JSON, but it is simple enough. Okay, not much complicated, but it's spread across multiple lines. So one record is not in one line. So starting from here, you should understand till here is one record, and then we should parse all of these elements and attributes inside this. Next, if you go a little bit more deeper on this, we'll go here and open the nested JSON file. So if you go here, so this is a little more bit deeper. So address is again a dictionary within this record. which has again attributes like city, state, zip. Orders is a list, an array. Array also, you call it as list. And in that, again, you have dictionaries. Okay. This is one order, this is two orders within that. So basically, when you represent in JSON, there are like two rules when corresponded to Python. A list can have a dictionary can have a list. Those are just two rules that you can use interchangeably. So if you choose a list, inside the list, it can have dictionaries or lists. If you have a dictionary, inside the dictionary also, you can have again lists. And again, in the list, you can have dictionary. So that's how the nesting works. Okay. Now, if I say order here, and then I'll put order ID, product quantity. So within this order, there are two items that I have ordered. So no, for this customer, there are two orders. One order is this and one order is this. Now within this order, in this order, I have product. Okay. So then there can be another dictionary which talks about features of the product for the laptop, or dictionary which says features of the headphones. So the nesting can continue. You can have a number of nesting structures, okay, levels in the nesting. So that's how it gets a little bit, keeps getting more complicated. But I think we should be good if we kind of stop at this level. Okay. Now, so these are the files. We will talk about how do we parse the JSON file, just like our CSV files, correct? So first I will go. So before that, yeah, do you have any questions on the JSON file structure? Yeah. Okay. Okay. So first thing, SQL types. So file path, I have to export the file first. So I will go to catalog, create table. We are in this folder. Go here. Where is this folder? This is date. Okay. So we'll go simple JSON. I will upload this. And then come here. So table slash, what is the path? February 2025, right? This is where we have to read. So for simplicity, I'm just putting all the files in the same folder for now. File name is simplejson.json, correct?
Yes, sir. Correct.
Okay. So see here how we are reading. So last time we did park.read.csv. Then we had a lot of options, right? Header is true, infer schema true, load, and then we gave path, and then all of that. So JSON, it already has structure built in. Okay. So you don't need to give header and all of that, infer schema and all of that. So here what we'll do, we'll say JSON and then file path, just park.read.json. That's it. That's what you use to read the JSON file. So if I run this, it should read. Okay. Yeah, it took the cluster, and then it should run it, read the JSON file, and display the data frame based on the structure of the data frame. Okay, now you can see here age 30, city, name 25, all of this. So this is how your data looks like when you parse from the JSON structure into a structured format, tabular structure, right? So just look at this. JSON file, this JSON file here, simple JSON. See here, name John 30 New York. Okay. Yeah, John 30 New York, and then same Jane 25 Los Angeles, Bob Chicago 40. So then with simple one line of command, you can read the JSON file and then display the data as a data frame. You can also see the schema. Age is long, long integer data type or long data type. City is a string, name is a string. So it's automatically taken that part. Or, excuse me, like we did earlier, we can also give the schema, just like with the CSV we did, right? So we can also give the schema name, which is a string type, age integer type, city is this, and then you can run the same schema file. So I will run this again, same thing, name, age, city. So this time we are explicitly providing the schema of the fields in the JSON. Okay. And then it will match with the schema, and then we see whatever true, false here. We will get all of that. Schema enforcement, but basically this is how you read the simple JSON file. Now, let's go if we have a nested JSON file. Which one we are talking about here? Nested JSON simple. This is the file we have. So I will go here and upload this file first. Catalog, table, 25, upload, nested JSON simple. Okay. This is done. And we'll go here. Go here, change the file path. Oh, it's already there, nested JSON simple. I just have to change the folder name here. See, you can create another folder within this if you want to separate the files. Under tables, you can just create another folder called JSON files, and then under that you can export. Under Feb 2025 also you can create another folder called, just like Windows, keep creating folders under each to keep the structure. You can use that. Nested JSON simple. Then see here, spark.read option we are giving here multi-line, because we know in our file, each record is not on in a separate line. So one record can span across multiple lines, right? So from here till here is one record. So that's why we have to set that option when Spark is reading. Spark.read.option multi-line is true. So which we are explicitly telling it that one record will be in the multiple rows, multiple lines in the file, and then dot JSON to read and file path. Okay, simple. Now I go df data frame, read it and display. So this is what it displays. Name, ID and name are straight enough. If you look at ID is one, name is on this. Now attributes is something, it's a little bit complex data type here. So it's a structure. Again, because it has key value pairs inside that. So that structure is actually directly read into it. Now, if you look at here, the data type, So this is very important. You should look at ID is long, which is an integer, name is string, but attributes is a struct type. Okay, so in the interviews also they'll ask you how are the complex data types, or you can explicitly talk about when you parse JSON, it parses the nested structure as a struct data type, and within the struct now you have the individual attributes eye color, hair color, which are strings, and that struct as is it will parse here. See here object, it's an object attributes eye color blue, hair color brown. Okay, same thing for this, but this is not how you want to store the data. So you want to split that again. I want to see John Doe's eye color in a separate column and hair color also in a separate column. So then you can apply the transformations. So how do you apply transformations on this is, see spark.sql functions import column, we call it flattening. Okay, so when you have a struct, okay, so you can do id name attributes dot hair color. So you can access the nested structure as column of, so these are the columns. You can select id, you can select name straight away from the data frame, but the hair color is under the structure attribute. So what you say, column of attributes dot hair color dot alias hair. So we are renaming that as hair. Okay, just for some sake, attributes dot hair color as hair, column of attributes dot eye color dot alias eyes. Okay, so 1 2 3. So then now you can display, you created a new data frame called df out or df transform, whatever, and then you can run this. So now you get id name and then hair and eyes as separate columns for this. So you have exploded. Okay, so always remember, if there is a dictionary, okay, struct type, the transformation will be one-on-one. So you get more columns when you have a dictionary. So that is something you have to always remember. If you have a dictionary, it will result in more number of columns when you parse it. If you have a list, okay, array, then it will result in more number of rows. Okay, so array will result in rows, dictionary will result in columns more. Okay, that's something that you need to remember when you are parsing or when you talk about it. When you say how do you parse JSON, you should talk about all of this process based on the nesting structure. I parsed. You should not say I will parse. You should always talk about, in one of my previous projects, we used to get JSON files as the ingestion, and then we wrote transformations to transform or explode the data within the JSON, where it had list and multiple nested structures. And then we had like arrays and struct types. Always pass struct types, it resulted in number of columns, more number of columns based on number of elements in the struct, and in the list based on the number of elements in the list, it will result in the explode into number of rows. So that's how you have to explain. And then you can take one example. So not just John Doe, brown, pearl blue. You have to come up with something, say, for example, organization specific, project specific data. Okay. You can talk about, say, orders. Orders is something everybody will have. So you can talk about, orders that we are getting on a particular day. It was a JSON file or something like that. So you can make up some kind of a structure, or customer data file. We used to get changes in a JSON where we get the customer and his ID and then his address and everything in a JSON. And then we take that, parse it, and update our system. So that's the most common use case that you can talk about. Now let's move. So I know going forward, we will increase the pace a little bit now that you are comfortable with platform and basic concepts. So let me know if you are not comfortable, if you want me to slow down, or if you need more time, or if you have any questions. But you can always, everybody should, I recommend to go through video at least once when you are practicing, and then do a more practice, then you will know. So if I talk about JSON, you should go and check on internet, get 3 or 4 JSON files and start practicing. Use AI if you want to generate code, write code by your hand, whatever it is, but you should be very comfortable. Only if you take some own data, that you generate own data, maybe from AI, ask AI to generate, or get files from the internet and then feed that to AI, ask it to generate the code, run it, debug it. So that's when you will learn. Okay, you'll get more comfortable to talk about it. It's all about whether you can do it or not. Everybody can do it. So if I get a day to do this, somehow I will be able to do it on the job. I will get AI to help. I will get internet, Google to help. I will get friends to help, whatever. But I will be able to get the solution. But the thing is, in the interviews, I should be able to talk about confidently. Yes, I have done this. Not I will be able to do it. Don't try to convince that yes, I will be able to do it. I know the concepts and all of that. Yes, I have done it, and this is how I had done it. That's it, at least at high level. So that's what, to get that confidence, you should have been already tried and actually get your hands dirty in running those jobs, looking at those errors, seeing those errors, fixing those errors. That's when you get the confidence. Okay. Now, so I have this nested JSON file that I want to. So this is a multi-line true. What did we run? Okay. So that is the nested JSON simple file, which we had only like attributes in this, a dictionary, which we have broken it down to key value pairs. Correct. Now we are going into the more nested part here. So where we have attributes, in a dictionary, which has individual attributes inside this, and a list also, again, which has individual dictionaries inside that, list of elements inside that. Okay. So this is a dictionary, this is a list, and inside the list, again, we have dictionaries. So how do we parse this nesting structure? Any questions, guys, here for these two?
No, Harul. Good with that.
Good. Okay. All right. Now, so let me again export this nested JSON 1 file here, upload nested JSON 1, open. This is done. So I can go here, just change the path where my file is. Here. Nested JSON. Again, this is multi-line, true, right? Obviously. And then I just say display df truncate equal to false. I want it to show the entire text. Don't truncate it, the data. Show me full data. Now, if you see these attributes, I want you to correlate here. ID, name, age are straightforward, right? Simple. At the top, level 0, ID, name, age, straight away it parsed it. ID, name, age. Now, then we have two complex structures. One is the address. So address, so if you go here first, let's look at the structure of the data frame. So age long, ID long, name string, these are straightforward. It got it. Address again is a struct, just like here we did the here attributes. Same thing, address is a structure which has these attributes, city as a string, state as a string, and zip as a string. So that part we are good. we know. Now look at orders. Orders is an array. Array or list, we use interchangeably these names. Specifically in Python, it says list. In Java world, it is an array, but for now we can use interchangeably. There are minor differences, but that's fine. So it is an array. Array means you have number of elements, more than one element. So if I have 5 orders, I can put it in array, and each order attribute, each order will have its own details within that array. So each element is again a struct. So this address is like address is a struct. Same thing in the orders, each element is a struct, which has attributes order ID long, product string, and quantity long. So this is the structure. So this is a struct at the highest level. This is an array, and within the array we have elements here, a struct here. Okay. Now when it parsed, address it parsed straight away, object straight, just like that, city, state, zip. And then you have, so second row, this one. Now if you go here, orders, if you see, now orders has 2 elements, 0 and 1. Okay, so John has 2 orders, right? So if you go here and see, where is John? So John has 2 orders. This is the first order and this is the second order. There are 2 orders. Now that's what we parsed here. Order 0 and 1. This is one order, this is one order. Now if you look at here, Alice has only 1 order. Okay, so only we have 1 row here, 1 order. So if it has 5 orders, we'll get 5 orders here in the row. Okay, now we have to parse these 2, right? We don't want to store everything. We want to flatten and save in one record. I want to see everything. Now what happens if I parse this? Tell me. Which one gets rows, which one gets columns? More rows, more columns. Address, what do you get?
City, state, zip as the columns.
Yeah. So we get city, state, zip as new columns.
New column.
Okay. Same thing here. Now arrays, what do we get? Ramya. You there, Ramya? I think Ramya is on phone. So that's
Order
fine.
ID,
Order
product,
ID,
and
order
quantity.
ID product, yeah. Quantity.
No,
Quantity.
that's fine. Order ID, product, quantity you will get. But do you get rows or columns here for array?
Rows.
Rows, right?
Yeah,
So
rows.
we have 2 orders, so you will get 2 rows. So here it is 1 row, this entire thing. But when you explode it for each order, so you get 2 rows. And all of this information will be duplicated because this order is also for John. This order is also for John. So this order will be again correlated with John only. Second row also for John. Everything will be repeated for John, and the new order will be put in that row. So when you parse. So that's why I said the basic rule is if you parse a dictionary, you get more columns. If you parse an array, you get more rows. And again, within the array, you have dictionary. So again, you get more columns. Now let's take it step by step. Okay. Now explode column, we import a function called explode and we put it column. So first we will explode the what you call the address. Okay. So we have done this df dot, we can say with column, we are adding new column city and taking address dot city. So we know address is the field here. It's called address. So address dot city, we get as city here. Address dot state as state, address dot zip as zip with column. And then we are dropping the address field. So why we are doing this? Let's see. If I have this, I'm not doing anything. So always remember with column, we'll add a new column to the existing structure. So existing will all be there, plus you get new columns. So I can do df dot with column and then display this. So we have See, address is there as is, just like from the top. Here, same address. Same, that is also there because we selected all the fields from the existing one. Then we have age, ID, name, and orders, but we added three new columns: city, state, and zip. So once we have city, state, and zip, I don't need again the same address, right? Here is the same information here and here. So once I have parsed it, created new columns, what I will do, I will go and drop this. I don't need this column in the new data frame. So just drop the existing address and give me city, state, zip as new columns. Now, once that is done, then I will go and do the orders. So order is an array. So what I have to do is df.with column, take order and explode orders. So orders is the array here. See, orders is an array. We are exploding the orders array and taking it as column called order. So I'm then dropping the existing orders one. So for now, if you want to see, you can take this off and then run it. So I'm exploding the orders. So when I explode the orders, so age, ID, name, city, state, zip, and orders, still I kept it here. But when I exploded orders and named it as order, so here see, each row will have only one order now. But you can see here, John. So because John has two orders, so this information is repeated twice. John, ID, name, age, ID, name, age. For this row, same address, but order is this one, 101, 102. So you get two rows from one row when you explode the array. And for Alice, there is only one order, so you get one row. Same, there are no new rows because only one order, but it is also exploded. If it is one row, you don't need to explode, but from the array, you can see it has become element now, dictionary. So once the array is exploded and you took out the elements as a structure, as a dictionary, now what is the next step? Once you have parsed the array, so now you have this structure: age, ID, name, city, state, zip, and order. What is the order type here? What is the order type?
Struct.
Struct. So what do you do for struct? Parse into new columns, right? So once we have multiple rows here, now within that again you parse into new columns. So again you take order ID, order dot order ID as order ID, order dot product as product, order dot quantity as quantity. Or you can say, just to differentiate, you can say product name. Okay, let's say I have product name. With column order dot quantity as quantity, I am dropping the original order column because I don't need it after I have parsed it. So I'll just run this. I see age, ID, name, city, state, zip, order ID, product name is laptop, quantity is 1, headphones quantity is 2. So all this JSON data, nested JSON structure is parsed into a relational data, right?
Yes.
Now all this information is as per the row. Now I can do the, let's say I want to query this data, right? So once you transform, what are the two steps? One, you can register as a temp view and then query the data. Two, you can go and save the data into a table. Same thing, nothing changes here. This is all same thing. You can do exactly the same for both. Okay. Good. So then we say df final dot create or replace temp view. I will say, oh, I don't, oh, okay. Yeah, I can just say cust orders, right? So just say create or replace temp view cust orders. So now this temp view is created. Then I can go here and say select person SQL, select star from first orders. Okay. And then I can say what is the name equal to John. Okay. So you get the data. Give me 1 second. Getting some important call. Okay, right? So this is how you can go ahead and just view, and then you can just write it to the database as a table or update the data daily, delta, all of that. Okay, so that is about the your parsing the JSON files. Any questions? This is just additional thing if you want to add. I don't think this is needed. I will just go ahead and remove. If you want to give nested structure, right? I'll just leave it here. You can just look at it. For the struct type, if you have a nested JSON, how would you provide the schema for the nested ones? Struct type data. Then within the data, you have employee ID, employee name, and then awards. And within the awards, you are adding these. So awards is a array of struct type. Data is a struct type. Awards is array. And within array, you have this type name. Year is integer. So just go through it. I mean, if you want to look at this. But yeah. Any questions before we switch the gears, switch topics, get into other stuff?
Yeah, no questions for me.
Good from us.
Yeah. Anirudh, Rahul, Ramya, all good?
Yeah, good from my side, Arun. Yeah.
Okay, fine. All right. So that is on the Databricks platform, processing JSON files. Similarly, there will be XML files you can explore. I think I have, but there are some issues, some debugging that you need to do. You can do that. Basically, for XML, you also need to have a library to parse it. let me see where you have that. So we'll talk about if need, but I would leave it to you to go do some research and figure out how you can do an XML. I'll give you some resources. I will give you also the a blog where you can use that how to parse an XML and try to do it. Do some research and analysis on that. I don't want to do every single bit here. I want to leave it to you to explore some few things. Okay. I will provide some resources and guidance on that. That's how you will do some research analysis and learn on your. That is very important. Doing analysis and figuring out things. All right. Okay. Now let's switch the topic to AWS. Right. So how many of you have created your account on the AWS?
Yeah, I have already have an account, but they've been charging me for some time. So I have completely deleted the account. So that was the case. So I was using the visualization tool. So they've been charging for that. So
Oh, okay.
that was the reason I was just deleted it.
Okay. So yeah, others. I think Nabi already has.
Yeah, I already have
Ramya, Anirudh,
Yeah,
Narasimha.
I have the account.
Yeah,
Okay.
even I have the account as well.
Okay. Okay. All right. Right. So everybody has the account. Let me go and check where we are with the. This one. And how many of you are comfortable with Google Colab? I know, Nabi, we have been working on Google Colab. Has anybody heard about Google Colab?
Yes.
Yeah, I was there.
Okay. So Ramya also knows, Nabi knows, and yeah, okay, all three of you. Okay. So let me open this up and see. I don't, my laptop crashed, so I lost some searching for the files. So there. I'll come back to this, but so we have gone this AWS, right? So when you log in, you see all of the services we'll explore completely tomorrow on the AWS front. But if we go here, sign in, let me sign in. Okay, sign in. So we'll look at the services tools. You have like Glue, AWS Glue, then EC2. EC2 is for processing, just like compute resources we do in Databricks, we create a compute. Same thing EC2 for virtual servers in the cloud you use to do processing. And Glue is data integration service that we can write scripts in AWS Glue. We look at it and then see Redshift is a data warehousing, just like, data storing and warehousing. We'll see which tools we want, and Athena is also there. So we'll see which tools we want to explore, and give you a sense of things. But most important of all of this is S3, definitely. So if you go to S3, it's just like a storage service. Think of it as just your Windows folders. Okay. All you have to go here. Folder is called a bucket. Okay. So you can create buckets and then you can upload files to the buckets. So bucket is simply, for simplicity's sake, you can think of it as a folder. Now you have a folder or bucket, and then with the bucket, you can go and create a bucket, use a bucket name, and then leave all of this as is. First, now just remove this. We don't want to block public access for you, You have to give ACLs, permissions. That is a different topic. But because there's no secured or private, personal data we are using, we'll just keep it public right now. And then go create bucket. So when you create bucket, so it will come here. You can see all of this. These are the buckets. If you want to give any URL for the bucket, you can just go here and say copy ARN. So that is the resource URL that you can use. For example, if you come here and say, so this is the ARN AWS S3 : Burak AI. This will give you the bucket nomenclature, how you refer to the bucket. Okay. Then if you open here this bucket, you can go and copy the URI for any of the resource in this bucket or URL. You can download or you can upload a file for here. So if you go here, upload. Okay. So destination is this folder, Burak AI. And then go here, add files. So this is from your local, if you want to add files. So I will go and say simple JSON. This file is added here. And then you go and upload. So this file is uploaded now. So if I click on this, it will take me to all the details of that file, where what is the object URL, what is the S3 URI, what is the ARN for this, size, type, key, all of this. You get the description of that file here. Okay, and you can download and all of that. See, it looks simple, but this is the most powerful feature that is being used in the industry. Almost every organization has some or the other kind of data stored on AWS S3. Every organization. Some might be heavy GBs of data, TBs of data stored on AWS. Some might be small, maybe less than 10, 20 GB of data or 50 GB of data that they will be storing in the S3. The storage on S3 is pretty cheap. Okay, and it is pretty powerful. So this is the most widely used storage for all organizations on the cloud for AWS, unless it is very, very critical, sensitive data like customer finance data or customer health data kind of a thing. All rest of the data will be here. Even that data will be stored in S3. Even personal data, health data, all of that is also stored by finance data is also stored by some organizations on the cloud, but they will have different versions. Standard AWS cloud, they have some private cloud. It's still cloud, but it is dedicated to that customer, that organization. They will have some private clouds. So they use that for more security, and then they put it there, that data. But this is very powerful, and you have to be very comfortable using it. This is on the S3. Now, this is the S3 file. Okay. Now I close this. I go here, go to bucket, select this and delete. So they say, if I go here, permanently delete objects, you have to manually type permanently delete and then delete objects. Okay, so that is deleted. Now this is adding and deleting files, but how do you access that? So for this, let's say we want to do something called Google Colab. I will give you a simple editor to run your Python jobs. So all I'm doing GenAI also, but within the Gen AI, I use mostly Google Colab to run all of those RAG applications or AI applications that I build. So it's simple. Go to say Google and Colab and then log in with your Gmail ID. It'll open something like this where you can go file, open notebook, just like Databricks notebooks we are seeing. It will be very similar to it, but this is not Spark. This is purely Python. Okay. So what is the difference? We will talk about later, but for now, differentiate. This is Python, not Spark. You can go open notebook, upload notebook, right? Thing like this. Let me see if I have open notebook. Okay. So I have this notebook I've written. Oh, move to trash. Okay. Then what do I have here? Okay. So see, this is the notebook, and first you have to install libraries. Okay. So we will go through it again. We'll keep using this, you will know. Just like you import any libraries in Java, also you add through Maven jar files and then you use it, import it. Same thing here also you will do. You have to first install the libraries. Pip install Boto3. So Boto3 is the library that will be used to access the S3. Okay. AWS to interact with. So Boto3 is the library. You will install it, import, and you have to give two keys, access key and secret key that you have. So I'm giving access key and secret key. You can go here. So tomorrow I'll take you through complete how to create this, add this. But today I'm just giving you a demo of things. Then you can go and say session dot client S3. This session is from Boto3 session. Using Boto3 library, we create a session to communicate with the AWS S3 using these keys, access key and secret key. I think you all know you have it. When you create an account, you get these keys. So use these keys to create Boto3.session, and then we get a client object for S3. So now you are connected to S3. You can talk using this S3 object. So I know I have a bucket called Burak AI. Now what I will do is S3 dot, you can use some commands, list objects v2, and I will pass bucket name. And then I can get the list of objects. So let me run this. Just writing data. Okay. So it will install the library. Basically, this is it will do in the session and memory. So once you log out or out of session, then when you come back again, you'll have to reinstall, run this and install it again. But it's simple process. It will be done quickly. So once that is done, you go and run this. No, why is not showing output? Yeah. See here, let me, okay, go here. Go here. Upload again. Add files. Simple JSON. Open. Upload. Back. And see if we can list that object here. Okay, see now it has a file, simple json.json in this bucket name. So it connected to S3, read the folder or bucket, and we are listing all the files in the directory, same as objects in the bucket. So this is the file. Okay. Now same thing, I'm just trying to create a new file from here to upload. So I have some data like this from the movies, and then file name is this indianmovies.csv. I will use the same S3, and now I'm using put object. So I'm writing the file. What is the bucket? I give the bucket name. What is the key? That's the file name that I will give, the key that to write the file name. And what is the body? Body is the data here that I want to put in that file using this. So I can run this. It says file indianmovies.csv uploaded to Rocky successfully. Now I can go here, go to this bucket. See, now I have two files. This is one file and this is one file. Okay. So go here, this, and I can say open. It will download. So I can go to my local downloads, Indian movies, open this and see this data, same data that I have uploaded from here. This data. Okay. So this is the basic how to connect using the CLI from the programs, any Python program or PySpark programs, how to connect using Boto 3 to S3 with these keys. So tomorrow I will show how we can add what it means here, the keys, how it accesses, and little more in detail into this. But today I want to show a demo of this. So I will share this notebook. I will share the video. I will share some more JSON file. I think already I have shared all of those files earlier. So go through it, try a few things, and then we'll come back tomorrow. I will ask you some questions on what we have discussed today. So just go through it and be prepared. All right. So I know we have covered a lot of concepts. I want to stop here. Any questions before we wrap up? Guys, speak up. Are we all good?
Yes, Harun.
Yes.
Yes.
So yeah, things will get a little more advanced going forward. Now we understand what data engineering is now. So now we'll be going at a faster pace, adding more tools, exploring new topics every week. If you don't follow and if you don't practice, you will fall behind. You will never catch up. So every week, whatever we are discussing, try doing that, try practicing it, try more than what we did in the class. Okay, don't just watch the videos. Try hands-on, try changing few things, try adding new things similar to that, adding new jobs, new files, new programs. Try it and be confident. That's how you will catch up. Otherwise you'll fall behind. Okay. All right. That's all for today. Let's meet tomorrow. More exciting topics.
Yeah,
All
Harun.
right. Yeah. Thank you.
Yeah.
Guys.
Yeah. Thank you.
See you tomorrow. Bye.